These are your notes for section 10.6, and we're going to talk about the difference between a population and a sample space. A population is an entire group of people or objects, and a sample is just a part of the population. And you can use a sample to make an inference or conclusion about a population. That means you can use a sample to make predictions, I would say, about what the entire population would do. So here's our steps for today. We're going to start by identifying what a population is and then decide what an appropriate sample of that population would be. I'm going to take that data and interpret it in order to make inferences or predictions about the entire population. So let's just make sure we understand what a population is. So I have two ideas here, either the students in a school or the students in a math class. Which one would be the population? And it would be the students in a school. The math class would be a sample of that school. Again, on B, would the population be the grizzly bears with GPS collars or the grizzly bears in a park? And it would be all the grizzly bears in a park would be your population, whereas those with GPS collars would be a sample. This next one, we're dealing with either 150 quarters or all quarters in circulation. The population would be all the quarters in circulation. You could never find all the quarters in circulation, so if you wanted to do a survey or something, you would want to use a sample of maybe 150 quarters. Finally, would you say that all the books in the library is the population, or 10 fiction books in the library? And it should be all the books in the library that is your population. The sample would be the 10 fiction books. Now that we have that concept down, let's kind of look at which kind of samples we would want to pick. So, when a sample is selected at random, each member of the population is equally likely to be selected. So you want to know the favorite extracurricular activity of students at your school. You need to determine whether each method will result in a random sample and explain your reasoning. So pick which one you think it would be and mark it on your notes. Would you ask members of the school band? Would you publish a survey in the school newspaper? Would you ask every 8th student who entered the school in the morning? Or would you ask students in your class? The one that makes it so that everyone is equally likely to be selected would be you ask every 8th student who enters the school in the morning. A will not work because not everyone's in band. B will not work because not everyone actually reads the school newspaper or cares about surveys in those. And D is only your class, so everyone is not equally likely to be selected. So it's important that you have an appropriate sample of your population. Here's another example. A new power plant is being built outside of town. In each situation below, residents of the town are asked how they feel about the new power plant. So you need to decide which one of these is valid. The first one is a local radio show talk. A radio show takes calls from 500 residents. Here this table shows the results. The radio station concludes that most of the residents of the town oppose the new power plant because 425 of the people who call in are against. Here's the next one. A news reporter randomly surveys 2 residents outside a supermarket. The graph shows the results. The reporter concludes that the residents of the town are evenly divided on the new power plant. Is that the appropriate one? Or you randomly survey 250 residents at a shopping mall. The table shows the results. You conclude that there are about twice as many residents of the town against the new power plant than for the power plant. So you have 3 sets of data. You pick which one you think represents a valid conclusion. Hopefully we saw that B would not work. 2 people is not enough. Okay? So the choices are between A and C. And then actually the most randomly one would be the 250 outside a shopping mall. The problem with A is that it only takes into consideration people who called in. These 500 people actually called in, so they are very passionate about it. But it's only people who listen to that radio station and who call in, so it's not a random sample. Okay, back to your notes. Please write down that an unbiased sample is representative of a population. It is selected at random, and it is large enough to provide accurate data. You always want an unbiased sample. A biased sample is not representative of a population. One or more parts of the population are favored over others. So let's see what's not biased here. You want to estimate the number of students in a high school who ride the school bus. Which one is unbiased? Mark the one you think is unbiased on your paper. Is it 4 students in the hallway, all students in the marching band, 50 seniors at random, or 100 students at random during lunch? So the one that is unbiased would be D. Now this, we'd have to assume that the school does not have off-campus lunch where people can drive away if they have a car, because that would taint your sample. 4 is not enough. Students in the marching band is just one population. Seniors is one population that has a lot of cars. Now it also says on your notes, what if you were trying to ask how many seniors rode the bus? If that were the case, then it would be valid to ask just the seniors at random. So your sample space depends on the question that you're asking. All right, let's look at this next one. You want to know how the residents in your town feel about adding a new stop sign. So which one is the valid conclusion? You survey the 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude that 75% of the residents of your town support the sign. This one, the 20 residents live right close to it. So that does not make it a proper sample because not anyone is equally likely to be picked. You singled out a certain population, so this is biased. Let's try the next one. You survey 100 residents at random. 40 support the sign and 60 do not. So you conclude that 40% of the residents of your town support the new sign. This one's random, so this one would work. This isn't unbiased. And so the conclusion would be more valid that 40% want it and not that 75% want it. Okay, this one's at the bottom of your notes. This is our final step. Once you've figured out a sample and you've taken some data, you need to make an inference or make a prediction using that data. So it says you ask 75 randomly chosen students how many movies they watched each week. There are 1,200 students in the school. Predict the number of students in the school who watch one movie each week. So here we have our graph, and the people who watch one movie each week were 21. So we're going to write a proportion for that, okay? And it would be 21 out of 75. We want to know how many is that out of 1,200. So you cross multiply and divide by your 75 to find out that there were 336. Now we could do that for those who watch 2 or more movies as well. We know that 24 students watched 2 or more movies out of the 75 that were surveyed. So then I want to know how many is that out of the 1,200. Again, you could cross multiply and divide to find your answer. This is what you would do to make predictions. You would use proportions. So 24 times 1,200, and you divide that by 75, and you would find out that 384 students watched 2 or more movies. So that's how you make predictions using the data from your sample space. Your homework is on page 444, and your homework quiz is on Schoology. Go ahead and get those done and turn them in to me.